direction आया है. Let's start.
Yes, recording now. Yeah.
Oh, okay. It looks like whoever joins using the link I sent will look as balas, like robots.
Yeah, that's why I sent the registration link.
I know.
Yeah.
But it's a bit late. Bear with those balas.
Balas, okay. So, guys, I think there are some parts where Uma and I both don't like it to be recorded. So that's okay, right? So I will let you know, Nagesh, whenever.
Yeah. I mean, and Guti, even if you say something by chance, we can edit it out.
Okay.
Yeah. Better just talk it out. Just voice it out. Somebody will stop.
Sure. Okay. So let's get started. This is going to work. All right. So this is the agenda for today. First three topics we'll be mostly talking about a very general, high-level view of what IoT is. How does the market look like? The market size, the trends, dynamics, okay, and popular use cases. Right. The first four topics are general GAN. The fifth topic is the products that I personally was involved in over past decade. I think I'm going to talk about 3 or 4 products. Some of them are interesting, so let's see if you guys like it. And then Uma is going to talk about healthcare use cases where she is directly involved in, and some of these are really, really powerful use cases which are directly related to your health and well-being. So pay attention, guys. And then last slide, we'll just talk about the current challenges in the IoT industry and hence opportunities. All right. So with that, Uma, why don't you start?
Sure. Generic overview of what is IoT for the novice. We did the survey. What we found out was we have a 50-50 split. Almost 50% respondents said they have familiarity with IoT. There were a few that didn't tell anything. There are others that said no, like they don't know anything about IoT. So I'm leaving all the complicated part to Guti, and I'm going to do all the easy, high-level views of IoT, I would say. But I thought it'll be good to use a very simple shopping experience example. And I mean, I was just going to use like 2 people, maybe Anant and Renita or somebody, 2 different people that are going to a grocery store and what is happening in today's experience with IoT. So when Anant goes to the store, somebody is watching him on a camera, right? And figuring out what is he doing there other than shopping. Is he really shopping for only the things he wanted, or is he just wandering around looking at other things? Many with the sensor technology adoption that is increasing, there's an RFID tied to study the shopping patterns and what is coming as a result of that. You can almost make your payments without using a point of sale system. You can just have your phone and shop from anywhere in today's world, especially with COVID. There's also data and analytics that is integrated to every single user, be it in retail. And Guti is going to talk about very specific retail examples as well. The ability to sign into systems without having any direct face-to-face interaction is increasing. So in general, if you have to think about and relate to what is IoT, you can pretty much, the 2 very simple use cases I can think of is your home. In your home, how you operate today, especially everybody is constrained with time, and given that we are, all midway of our lives, it's almost, you're constantly, like you wake up, you may have a coffee maker that's already set up with your smart sensors and it's doing its work at every time each day. And then once you come down and your Alexa is programmed to remind you of your shopping lists and things like that. I think there was also a connected video that we shared that gives you a very high level view of how the connected aspect of day-to-day life. So there's this whole integration, I would say, of our physical life with our digital lives for the most part. So I think most of you are familiar with this. So if the concept of what is IoT is clear, Internet of Things for most of you, then we'll go on to the next page. That's essentially, any surprises from the survey results. Average number of connected devices. It was very interesting to see many people said they have almost 8 devices that are connected with a maximum of 20. So I'm really curious to hear from the 20 connected devices users, what all do you have? Like anything out of the box that would be interesting to share with the group?
Well, I think I was one of those 20 people. I have this Fitbits, 2 Fitbits. Then I have connected door home lock. Then I have the video camera, which is the doorbell camera, which is also connected. Then I have in my kids' room, I have a camera for the kid and the playing room. And that's just the cameras. Then we have computers, iPads, hard drives, a lot of remote connected things. So even the washing machine is connected. I get a notification on my phone when the laundry is completed. Yeah, I think 8 is an
I'm one more with the 20. Same with the sensors for all doors, cameras, the Nest home system, and then there are laptops, of course, and then the Google Homes in each room, the TVs and everything. Yeah.
Yeah, smart TVs is probably one of the most common. Yeah.
Alexa, two smart TVs. Yeah.
That is fascinating. Yeah.
And smart people.
Yeah, guys, only I would add one more thing is usually I use this when I actually went to India last time, actually, right? And I've used our garage or outside light control. I used to switch on and switch off from India. So just to make sure people feel that I'm here. So, and also my parents' house too has some few cameras there, and then some connections. So I could see what's going on there as well.
So anybody has connected car? No?
Connected car?
Yeah. So can you remotely start your car?
Somebody had a Tesla, right?
In fact, Chevy also had it. I had a Chevy Bolt, which you could start and condition from your iPhone.
Yeah, I have mine too, actually, Mercedes.
So Gutti and Uma, I mean, this is Praveen, I don't have a lot of devices that connected at home, maybe around 10, but in business, we have about 100, more than 100 devices which are connected, but those are machines.
Yeah.
And measurement devices.
Yeah. We'll talk about those, Praveen. Okay.
Yeah, that's a great segue. So I think, Praveen, thank you for bringing that up because you're almost introducing the concept of industrial, like how, we use assets, connected assets from a work standpoint versus, from a day-to-day, daily life standpoint. So a couple other topics that people expressed interest in, and we have tried to address some of those. And again, feel free to bring up examples from your daily life that you may have experience in. Monetization of IoT was mentioned. Security obviously is a big one, and implementation. So I think we will cover, between Gutti and I, we will cover most of this. So we can move on to the next slide, Gutti.
Yeah, so Anant is actually driving in a connected car he's like all these amateurs are boasting about it. I'm actually driving in a connected car.
And he's connected to all his girlfriends also.
All right, so this is a slightly advanced slide, not necessarily very advanced for most of you, probably. So what I try to show here is, the main message here is IoT is just not about sensors and things, right? You have this sensor and things that you actually interact with at the bottom here, and which are called end devices, right? So that is only one layer, but to put together the whole IoT solution to create some value, you need other layers as well. Right, so you typically these end devices that you interact with, it can be a camera, Nest, thermostat, or a connected car, or a vehicle, etc. They talk to something called a gateway or edge. Okay, so the end devices tend to have very limited intelligence. In the sense, when I say intelligence, basically a limited memory, limited compute, and some basic sensors, right? But the edge gateway tends to have a slightly higher resources, okay, in terms of compute or memory. So, so basically, so these end devices communicate to these edge gateways, okay, which in turn communicate to the cloud, where you can do advanced analytics, right? And then this is where at the top, at the top you consume those insights or those output of those analytics, right, and the apps. Right, so this is the whole stack that you need to put together to have a successful IoT, solution. Even a simple use case like Nest also has all of these more or less, right? So sometimes these assets themselves talk to each other as well. Okay, often the technologies you probably hear like Zigbee, LoRaWAN, Sigfox. Actually, those are the technologies these devices use to talk to each other as well as talk to the edge. And typically the connectivity between edge and the cloud is over cellular or Wi-Fi, right? So just wanted to give a complete overview of stack, what it takes to put an IoT system or a solution together. All right, no questions. So I'm sure these are some of the examples we already talked about. This Nest, I think everybody recognizes it, and probably some of you already have it. I'm surprised that nobody has this. This is Philips Hue. It's pretty popular product from Philips for consumer lighting. Basically, it changes colors. It doesn't do much. There's not much value, but it changes colors based on your preferences or mood, basically. This one, the interesting one, the smart pill. This is a pill that can be ingested, and when it gets digested, it sends out a signal. Before it gets digested, of course, it sends out a signal that the particular pill was consumed. Right? This is used in just to ensure that patients are adhering to their drug schedules. Right? The last one here that you see, probably nobody would recognize this because this is the product that I launched in China and it's probably only available in China. This is a smart air purifier. We'll talk about that in the coming slides. Any questions, or it's too simple for you? All right. If no, let's move on. So this is just a slide giving an overview of the market in terms of numbers, right? It's a huge market. There's no doubt about it. Depending upon which report you refer to or which consultant you speak to, the market is anywhere between $500 billion to $1 trillion market, right? And the first graphic basically gives you segmentation by verticals, right? Manufacturing is pretty huge. Healthcare, Uma is going to talk about it, $73 billion. Smart cities, again, huge market there. There are many verticals, right? There are multiple verticals. I did not put all of them. If I had put all of them, the graphic would look really ugly. So basically I clubbed all of those rest of the verticals in this 500 in others category, right? So basically utilities, oil and gas, natural resources, mining, all of those come in that others bucket. So bottom line, huge market. Each of these verticals are also huge in themselves, right? Now this is how the market is segmented by verticals, but if you look at the market from the vendor's perspective, right? The companies who are supplying IoT solutions or parts of IoT solutions, this is how it looks like. Again, rough segmentation, right? So 30% of the market of the $1 trillion market I mentioned above is basically solution integration or system integration, right? Companies like Accenture, IBM, TCS, HCL play into this category, right? The SI services. Then other 30% is software platforms, products, companies like Microsoft, Azure, Amazon, AWS, IBM, Bluemix, Watson, ThingWorks, PTC. So those are the companies that play in this category, right? This green pie here. And then hardware players like the companies that make those smart devices, make those edge gateways, and semiconductor companies which make chips that go into those gateways or devices. That's the other 30% of the market, 20 to 30% of the market, right? Connectivity. We talk a lot about NB-IoT, cellular network, 5G, all of that, but it is actually really small if you think about it, right? Compared to other pieces, right? So all the telco players, basically that market is around 10%. So when I talk about connectivity, I'm talking about the pipeline between different things and the gateway and things and the gateway and the cloud, etc. Right? So it's a small market. It's relatively small. It's not that small, but it's relatively small. Now, that is one of the reasons why all these telco players like Verizon, AT&T, all of those guys are trying to move into offering software platforms or trying to even offer even system integrated services or even solutions, right? So they are trying to move into other parts of the business, more trying to move up the value chain. Actually, almost every player is trying to do that. Sometimes if you talk to companies like semiconductor companies like ARM or even Intel, they have an IoT platform too, right? They're just not supplying chips, but they're also trying to offer the IoT platforms. So there's a lot of jockeying going around in this market because it's still a nascent market. So each company, of course, is offering whatever they are good at, but also trying to get into adjacent spaces. So in terms of our numbers, again, the numbers are huge, right? So today they say probably around 20 billion things are connected. Okay, probably. Okay, that was the projection last year. Last year, the number was around 10 billion. Now they say it's probably 20 billion, but we don't know. Pandemic might have reduced that number a little bit. We will know this next year, I guess. But having said that, this number that I have posted here, they are from last year. Number of connected cars today actually are 150 million, at least 150 million. Well, smart cameras and smart meters and cameras we already know, right? Lighting is also another one. More than 100 million lights are today connected. Okay.
Hey, Gutti.
Hey, Ashish, sorry.
Yeah.
Quick question, right? I don't know if you two are going to address this technical aspect of, the connectivity, right? I mean, the one thing I hear in this context is running out of those IP numbers. How do you address these devices? If you're going to talk about it later, it's good. I just wanted to check.
No, I'm not going to. I don't have a specific slide to it, but I can address some of it. Right. So there is, first of all, IP6 is coming, right? So that will give you a large number of potential to connect a large number of things.
Oh.
And second is, not all devices need to have an IP address, right? Some of these devices that talk on Zigbee or Bluetooth, they don't actually really need to have an IP address. So they are behind a particular firewall or behind a particular edge gateway. They don't need to really have an IP address.
Right. Yeah, they're probably like NATed or something. Okay.
Yeah.
Right.
Hey, Gutti, how much is this influenced or connected by 5G stuff in terms of bandwidth or to make it work?
Yeah, interesting. Good question. I think Dhimant will cover that in a big way, probably in his next talk. But 5G, actually the adoption of 5G is being driven not by telcos, but is driven by the industries themselves, right? One of the reasons why would anybody go for 5G is basically, if you have use cases which require very, very low latencies, right? You need to make quick decisions right on the edge, right? So there's that you need a high bandwidth there. So low latency use cases, basically controlling or monitoring a manufacturing line on a shop floor, right? Those would potentially need 5G. Okay, 5G is going to most likely replace Wi-Fi. That's some pundits are saying that, right? It's going to be far more secure. Has a higher bandwidth and has, can support low latency use cases. But I think if you look at 5G, there are three phases: the phase 1, phase 2, phase 3. The phase 1 that got deployed that we see today is mostly around consumer apps, basically the smartphone and video gaming, all of that stuff. But the phase 3 is where actually massive M2M communication will be supported, and that is still not yet starting to roll out. It's going to come, but it's not starting to roll out. Sometimes, it depends upon who you speak to. Sometimes people say 5G is a solution looking for a problem, but some say it has a real application in specific use cases like manufacturing, mining, where you want to have private dedicated networks.
Okay, thanks.
Hey Guti, this is Sachin. I have a question, basic one.
Yeah.
You mentioned about the big players like HCL, Accenture, IBM, operating in these SI as well as the software platforms. Why is it that, my question would be, what are the imperatives? Why you see those big guys operating in this? It's relatively, new, business opportunity that is actually coming. Yet to be explored, the kind of market that we're talking about probably, right? So what are the imperatives? What would make, let's say, new entrant to get into this business? What are the essentials? And what sort of a leverage these companies have, which gives them that kind of a positioning today?
Yeah, I think I was going to talk about it in the very, very last slide, but I think we can address that.
Oh, so sorry.
No, it's okay. No, it's okay. This is actually a very good question, right? From SI perspective, I can tell from SI's perspective, right? Why the company is still looking to an SI to help them implement IoT solution, right? One of the reasons is IoT ecosystem is still complex and evolving. Okay, so most of the companies, the customer clients, right, end users do not know where to start. Okay, are not able to. So there is a lot of consultation required. Okay, about how IoT. You start from the POC, then you go to a pilot stage, and then you figure out how IoT actually is going to change your existing business processes, and do that at scale. All of that needs a little bit of hand-holding, okay? Depending upon which vertical you speak to, right? Manufacturing is slightly advanced, but in healthcare, Uma can talk about it. They are adopting IoT now, but when they are adopting it, they need a partner with who they can, do this transformation journey, right? Right from the POC stage to the scaled implementations. So there is a need. There is definitely a market need for such consulting as well as system integration. First of all, custom consulting services. Then there is the reason why system integration is needed is because none of the actually enterprise level IoT solutions are plug and play. Nest, you can bring Nest, install it, and probably connect to it by yourself, right? That is very simple, simplest of use cases. But most other IoT enterprise grade applications are pretty sophisticated and require system integration because they are not plug and play, right? So there is a need there. Now the companies who have already had goods position in the market where they are managing IT infrastructure, right, and offering IT applications, IT solutions, they are well placed to get into this IoT space. Did I address your question?
Yeah. Certainly. Thanks for that. Yeah, I think
yeah, and to add to what Gutti said, Sachin, I can tell you on the healthcare side, couple things. A lot of what's evolving in the IoT space is based on partnerships. So if you take like the three basic players as an example, Amazon has its own life sciences wing. And when you have to look at quick opportunities for pharmaceutical companies, they either work with existing partners that may be providing their equipments or supply chain base, and a big player like Amazon that would also have the technical know-how of how to make the cloud platforms work or have a large presence in those areas. So working together with these type of partners is becoming an advantage. Same thing with Azure, Microsoft Azure. It's also lucrative from a business like money on the table standpoint, because there is a lot of cost advantage on the supply chain side where you are able to significantly reduce cost. And Google, obviously, I'm seeing more of Microsoft and Amazon than Google in general in the what you call as the pharma or life sciences, biopharma space. But I'm pretty sure on the other aspects of healthcare, all the three players are pretty strong.
No, so I think Microsoft Azure and AWS are the two big gorillas in this industry, not only in healthcare, and other verticals as well. Okay, Google is a distant third at this point in time. And then there is a long tail, right? If you look at your IoT platforms, there are at least 300 plus IoT platforms today, right? Of course, there's going to be consolidation eventually, but the two big guys are Microsoft and AWS at this point.
Gutti, again, a very basic and silly question. Is it because they have owned that whole cloud computing space?
Yeah,
because
that is one main reason. Okay, all of these startup companies, when they start with an IoT solution, they probably, it's easy for them to start if they don't have to buy all IT resources and just go on the cloud and create an account and start building their applications. Right, so that is definitely a big reason. And Microsoft has been pushing very hard Azure platform and Azure IoT platforms as well for last 3-4 years. Very hard, actually harder than AWS. AWS has good market presence mainly because developers love it. But and the reason Azure is getting traction because Azure is putting a lot of money. I don't know if Monty's on the call, but they are pouring a lot of money into Azure platform and Azure IoT platform. So most of the enterprise customers are actually talking about Azure all the time.
Okay.
Even in my company, investment bank, State Street, they are giving everything for free. They just want the market share. One of my neighbors is working exclusively. She's from Microsoft. She works exclusively with BMW connected car program, and nothing is getting paid by BMW. They don't care.
We actually bid for that BMW. We lost, by the way, the BMW the connected car program. Interesting.
So, Gutti, I have a question. This is Praveen again. A lot of my questions are going to be very specific, so if I may bore other people because they are relevant to my business. Okay. So, Gutti, we have our own framework.
Okay.
We tried. So we haven't tried AWS or Azure IoT framework.
Yeah.
But so we had a very senior developer who or a designer who developed it for us.
Yeah.
After that framework is being used by a very low-end young developers.
Yes.
So every time we try, and
try to evaluate that, yeah, should we try to use AWS IoT or Azure IoT? Is that going to eliminate the need of IT resources in our organization? We often find that our folks who are young IT folks are more interested in using our own framework.
Yeah.
They say they find it easier to use. So are we missing something here, or what is
yeah,
it?
so, yeah, so,
Azure?
yeah. Yeah, so yeah, I think very good question. By the way, I'll also give my example, right? So when I'll talk about Philips Lighting platform later on as well, where it was built in-house. Okay, the whole framework was built in-house. But later on, what you find eventually is this is again my opinion is the amount of money that Azure and Microsoft and AWS can put in, right? You can never keep up with those, right? All new changes that are going to happen. You can never keep up with those. These guys are putting in a lot of money, right? If you want to maintain your IoT platform, go ahead and maintain it. But if your value of your product is not in the platform, but it's somewhere else, then I would rather focus on that part, right? Because the IoT platform is for me, if you think about it from an application point of view, it's just an infrastructure, software infrastructure, right? Rather you will leave those to the companies who are very good at it, Microsoft and AWS, right? And they can keep continuing pulling in. I don't know what is the budget for Azure, but you can never match that budget, right? When it comes to keeping up your IoT platform up to date, right? All these new security threats come along, breaches happen. So these guys are very fast to fix those gaps, right? If you have your own own platform, I don't know how much money, even Philips could not do it, by the way, just to give an example, right?
So the question really is, this is one worry that as a business owner I have, that today we have about 500 devices. So that's why this platform is still working. Is it going to work when we have 10,000 devices, 100,000 devices? Is this going to fail? We don't know.
Yeah, so exactly. Scalability is another big issue, right? So, of course, these guys have proven and tested platforms. So I would continue. I don't know. I mean, my advice would be at least start evaluating the IoT platforms. For scalability's sake, as well as just to keep up with whatever technology changes happening in the market, right? Just to keep up with that. Because if you
can do a hybrid. Sorry. Yeah.
Go ahead.
No, go ahead.
No, so that's what I would suggest. And most companies I have seen are doing that, right? Again, probably the platform, which basically connected to this implants.
There's nothing proprietary in here. So I think we saw the overall market segment and the market size in what Gutti just shared. Most of my experience since I left KREC has been, in the healthcare space primarily. So there are three broad areas, in the healthcare space that currently IoT is being utilized. Obviously, the IoT healthcare market is already over $73 billion and it's continuously growing. That can be discussed in a separate group there. It comes down to a couple of things like scalability, how quickly you want to get things going, and also how much money you have initially to invest, and the expected ROI in how many years, those type of factors. So getting back here, pharma in general is healthcare overall is adopting IoT quite a bit. So on the prevention side, almost everyone will either have an Apple Watch, or you are able to track your lifestyle constantly, getting into any type of what they call as recurrent diseases. On the treatment side, two examples I wanted to call out here that are pretty prevalent is the augmented reality aspect. On the augmented reality, I think it can be applied in multiple ways. One is in the concept of manufacturing a drug. So how do you, there is a lot of remote monitoring or remote supply chain type needs that are being experimented in that area. The other aspect is even surgeons and doctors having the right expertise to save a life. Augmented reality is increasing in use. The second aspect is adherence. A real example I can think of is asthma medication. So earlier, Bangalore, I used to have allergies, and many times they'll recommend steroids, or they'll give you these inhalers and ask you to take it on days the pollen level is high or you're exposed to more dust than usual. And the way the inhalers are set up, when you administer a certain dosage, the entire dose is not going into your body. And even though you think that you're taking that much, especially with kids who have pneumonia or kids who are into these type of medications. So with the recent advent with IoT, what they call soft sensors can be put into the inhalers, and the soft sensors will not only track whether you're getting the right dosage to your kids, it will also, you can connect it with your mobile app, have your healthcare provider be notified on how you're doing. So in situations where somebody has to constantly take this, the ability to track adherence is increasingly influenced by IoT, and it's a very good impact, I think, in general it's having on people. On the diagnosis side, I think one example I can call out is the electronic medical records. I mean, if you go to your doctor's, I mean, there's an FDA, at least in the US, there's an FDA regulatory need to maintain records for 30 plus years. And many times you walk into your doctor's office, they are like trying, or you move from one state to another, they are trying to track, oh yeah, do you have my chart, or where do I get all your previous records? So I think that whole need of maintaining your patient records in one place is one example I will call out on the diagnosis side, where any history of diagnosis and also being able to remotely transmit the diagnosis patterns very quickly between two different doctors is also increasing. So those are, we'll talk more about this, in each of these areas, how IoT is being utilized, but I just want to call out these three areas at a high level.
Okay, great. So, can you guess how many smartphones do we have today on the planet? Any wild guesses?
10 billion.
8 billion?
Yes, around 7 billion.
Probably more than the number of people on the planet.
Yeah, more or less. Today, so around 7 billion, so one per person. So IoT is already, the connected devices are even higher than that already, right? So we are talking about $10 to $20 billion, anywhere between them. Right, so what is driving this, right? So there are business drivers on one hand and the technology enablers on the other hand. So on business drivers, basically firms or companies are trying to build new revenue streams, right? The greed is a very good motivating factor. But better than greed, it's a fear, right? A lot of these established companies who have huge market share in whatever product that they sell, they are afraid that somebody else might come in with a smarter product, a connected product, and then undercut them. So they basically try to preempt that by launching themselves a smarter product, even though they have a very profitable business of selling existing dumb products, right? So fear and greed are two good drivers. Consumer behavior, of course, especially the millennials expect these products to be smarter. They like to interact with the products, right? So the consumer behavior also is driving the adoption of IoT. And cost efficiencies, that's always there, right? So every firm wants to reduce their operational expenses, reduce their energy costs, maintenance costs, improve the productivity of employees, et cetera, et cetera. So these are the business drivers largely, which are basically driving the adoption. On the other hand, the technology enablers are basically helping this adoption, right? So the key technology enablers are basically Moore's law. It's still going strong. I think Hemant is going to talk about it in his next talk, where you pack more and more transistors in the same area, okay, and the cost goes down, the form factor goes down, and so you can put in a lot of intelligence in the smaller devices as well, right? So that is still ongoing. So that is one huge enabler. Pervasive connectivity is almost there everywhere. Wi-Fi, cellular connectivity is almost everywhere. That is another technology enabler. Now, also, we figured out, I think at least the cloud guys have figured out how to handle huge amounts of data. We are still probably far away from how to analyze the data, but at least know how to ingest and store huge amounts of data. So that technology also has gained speed quite a bit and is helping adoption of IoT. Right. So some of these technology enablers are basically driving this adoption. Okay. All right, so moving on. So I just told you how fast the adoption is happening, but now I'm going to tell you it's not fast enough compared to some certain technologies, right? So if you look at the adoption of a technology, when a technology is introduced, this chart actually shows, this is a slightly dated chart. It shows an example of how when a technology is introduced, what curve it follows when it comes to penetration in the market, right? So typically most of these technologies have this S curve, right? For the first few years, nothing happens. Only early adopters adopt it. And then after a certain point, the mass market starts adopting, then you have this upward slope. And then after a few years, after some certain number of years, then there is plateauing happening, right? you reach around 80-90% of the penetration. There will be always some laggards who will never buy a telephone maybe, right? But yeah, you reach around 80-90% of. So there is a typical S-curve of any technology adoption. Now, some of these S-curves are pretty steep, right? If you look at smartphone and cell phones, most of the adoption happened within a decade or two, right? So really, really fast. So they look like a hockey stick, while some were slower, right? Like telephone, it took 100 years, okay? The rotary telephones. Right, so so where I believe IoT is somewhere in between. It is not going to have a hockey stick like cell phone or smartphone had. It's okay. One of the reasons, and few of the reasons why that is the case, is going to be because there is no killer application for IoT yet. I believe. Okay, that's my personal opinion. So when I talk about killer application, right, the application which basically is so good, so desirable that it drives the adoption of underlying system, underlying technology, right? So if you think about it. For internet, the browser was the killer application. For PC, probably the word processor or the spreadsheet was a killer application. But there is no such killer application, I think, for IoT. That's one of the reasons why the adoption may not be as fast as we think it's going to be. Besides that, it's not one single market, right? It's not one single technology even, right? It's a bunch of technologies, bunch of markets, right? We just showed you the segmentation of markets, right? So there's not a single market where few players dominate, right? So smartphone today, we have what, 5 or 6 players dominating the market share, like probably 50% of the market share is controlled by those 4 or 5 guys. That is not going to be the case in IoT. So basically it's fragmented and largely still non-standardized, right? So if you just look at the market, right, it has a long tail, right? So you have millions of LED lighting connected, you have millions of automotive subsystems connected, but at the same time, you also have these parking meters, vending machines. No one company is going to cater to all of these, right? So you are going to have a fragmented market for a long time to come, right? That is one of the reasons why I believe it's not going to have a growth like a smartphone market had, but still it's going to grow faster than traditional IT business, right? So 20-30%, no slouch speed, right? It's still very fast. So fast, but not fast enough that I just led you to believe so far, okay? If no questions, I'll move on. Okay. So what are the popular use cases, right? So the popular use cases are actually driven by the value creation, right? So value is created one of two ways only, right? Either revenue or cost. You increase the revenue or reduce the cost, right? So most of the use cases that you see in IoT can be bucketized into two these large buckets, right? So in revenue, we talked about what are those drivers, right? Building new revenue streams, building new business models, increasing the market share, all of that stuff. Or in the cost, reducing the energy and maintenance cost, improving the productivity. Those are the reasons why people want to adopt IoT or build IoT use cases. Under revenue category, these are some of the use cases. I'm going to talk about product as a service in detail a little bit because I think it is pretty disruptive and is disrupting industries. And plus, I have some experience with that business model in Philips. Right, so I'll talk about that. In the cost category, I will talk about predictive maintenance. If time permits, we can go in details there, which basically helps improve your operational expenses. Right, so largely, main message here, largely two sets of use cases. One that improve the revenue, the other that improves the cost. Okay, so a product as a service. This is the most actually strongest trend I have seen over the last 1 decade, market trend basically, right? Especially among the manufacturers of products that tend to have long life cycles, right? These are the companies who not only make money when they sell the product, but actually make a lot of money, much more higher, probably 2x or 3x times of money they over the life of the product by providing replenishments or services, etc., right? So those companies are actually moving towards selling boxes, selling products to selling services. And eventually the eventual goal is to move towards selling the whole thing as a service, right? So let me explain, right, that in detail. So you have a printer, okay? A company like Xerox or HP will sell you a printer. Okay, so if your company just sells the product, then you are here. The value you are creating for the customer as well as for yourself is probably pretty low, right? But if you start offering services on top of your product, like offering toners, right, where you directly offer toners as a, for example, HP or Xerox directly offering a toner to you. That is a service that it is offering, okay, on top of the product, right? So that is that is a little advanced form of business model, and even more advanced is basically managing, offering services not only on or top of your product, but also to the ecosystem, right? Meaning also to the your competitors' products as well as other channel partners. Just to give an example, right? Xerox could be offering toners not only for their printers, but also printers of HP or some other company. They could also offer services to the dealers or distributors in the channel. For example, right? Xerox doesn't have, I'm just giving an example, right? It probably doesn't have logistics infrastructure in certain country. And so the fulfillment of toners is done by third-party dealers and distributors, right? Now, Xerox can offer a service to those dealers and distributors about where the demand for the toners is, okay? Who can go serve Xerox's products, right? So what this does is basically it increases your share of services in the products that you sell to the market, right? Earlier, if you think about it, if you're not offering these toners, then that toner was being sold by some other third party, or sometimes even fakes. There are a lot of fake toners that are being sold in the market, and not only in Asian parts of the world, but also here in the US. Now they just take that away, right? So today, managed printing services is a very popular business model. Almost all companies offer that today. All these printing companies offer that today. Okay, so wherein you charge your customer by number of papers printed, rather than customer doesn't have to bother about buying the hardware, the infrastructure, and doesn't have to bother about upkeep of that machine, etc., etc. So this is the journey, maturity journey, and IoT plays a key role in this journey, and I'll explain how it plays a key role. Before I do that, if no questions, I'll just give another few examples. Yeah.
Like for example, we have an investment in an electric vehicle company.
Yeah.
And we're exactly facing this. There are newer companies that are, let's say, ride-sharing companies that are now offering, rides as a service. And I'm assuming that word servitization was not a typo.
Yeah.
But, looking at other industries, etc., is it a very fundamental, because we face this question today in India, is it a very fundamental shift in the power balance? Because historically, let's say if Hero had a lot of power, going forward, the ride-sharing company has all the power because they can pretty much shift whoever the producer of the vehicle is, assuming that so is this across industries? Do you see a shift from, like in the printer example you gave?
Yeah.
HP was the largest printer guy, and he continued to be the largest guy going forward. But do you see completely new players come in and completely upend the industry, basically by offering a better service?
Yeah, so I think it varies by industry to industry, I would say. Okay, I have not seen such. I'll talk about appending example in lighting, Philips lighting. I'm going to talk about that. But I think it varies from industry to industry. As you said, HP was a big printing company and still is. So the Uber model that you talked about, right? Is probably probably true for that particular ride sharing. There might be a case where it might be a case there where the power is shifting towards the companies that are offering services or which have high touch to the end customers or end consumers. And I think that okay. The bottom line is that I think whoever owns the customer or the end consumer probably has the power. And this is what these companies are trying to do. If you sell a product as a box, you actually do not have any touch with the customer. But if you sell a service, then you have to have the intimacy with the customer. And so that is probably the reason why these companies are moving towards servitization. And there's one reason, and the other reason is the fear that you just talked about, that somebody else might come in, might come in and start offering it as a service. And then and eat my lunch, right? I have not seen a seismic shift yet in any of this industry that actually I am aware of, but that is a fear, right? The same thing happened with autonomous vehicles. Actually, the automotive companies fear Google and Apple will basically eat the lunch, right? And the manufacturing of car itself is not anymore, has a strong competitive advantage. It's the intelligence in the car, which is a strong competitive advantage, and Apple and Google's of the world are better than them. So that is a fear these automotive companies have. I have not seen, at least the industry that I work with, there is a specific shift happening. Yeah, does that address your question? Yes, or maybe not completely? Yeah.
Yeah. Thank you.
Yeah, Ashish, can I add one more thing?
Yeah.
So there is a book I recently came across called Big Shifts Ahead. I would recommend. The other day I was having a conversation with Vijayanand, and he was saying that look for opportunities around you when you think about starting something on your own. And I started reading that book. One of the phenomena that is happening off late with this generation, people who were born in the 2000 and after, early 2000s especially, they are investing or living in a shared economy. They love that. They don't want to buy or make big investments.
Yeah.
So if you look at IoT, and especially what Ken was mentioning about ride as a service and things like that, that phenomenon is also driving this exchange of data and how you can leverage this infrastructure that is being laid out.
Yeah, I think that's it. Fully agree. Yeah, so millennials don't like to own stuff; they just like to enjoy and enjoy stuff, right? So product as a service is the model for them, basically. Without owning, you are enjoying the fruits of the product, right? That's the whole point here. Right, so some of the examples in product as a service, right? Power by hour. This is actually very old. This has been there for 30, 40 years. Right? So this is nothing to do with IoT. It has been there for some time. Okay, this model, but it was mostly a financial trickery there, right? It was mostly a financial model. The way Rolls-Royce sold engines to airlines, right? Where they don't have to buy the engines, but they just buy the propulsion, right? But with IoT now, they can do the same thing much more efficiently. Hence, they reduce the cost to serve the customer. Right? The Rolls-Royce, what Rolls-Royce has done is reduce the cost to serve the customer by connecting these things to cloud. Basically, I'll explain that in a little bit in detail. But just want to give you examples here. Power by hour has been there for decades. I talked about a managed printing service and pay per lux. Anybody knows what lux is? It's not, of course, soap.
That's interesting. Can you talk
Brightness.
Brightness. Yeah. It's illumination, yeah, the light. So instead of selling light, you are selling instead of selling light fixtures, lamps, you are selling illumination as a service, right? So you basically guarantee certain level of illumination in certain parts of the building or city with certain SLAs, and the customer pays for that illumination, whatever they consume, right? So if you are a city, you don't want to own lighting infrastructure. All you need is light, right? So why do you have to buy all these poles and the fixtures, et cetera, right? So this is the model that Philips pioneered, pay per lux, right? This is the picture of Amsterdam Airport. Today, Amsterdam Airport works on this model, right? All the lighting inside the airport is owned by Philips. It just ensures lighting to a certain level of quality, and Schiphol Airport pays a fee to Philips every year, right? So I was involved. So I was at the right time at the right place. So this started around 2010. I'll go into the little bit details of that business model, pay per lux. Okay.
Do you see this?
I think PD has the same model, right? Pyaro offers a similar model.
Sachin, it's similar, not exactly pay per lux. Interesting to hear. I'm more. Yeah, not exactly similar. But I've heard it from Gutti earlier as well. So
okay. All right.
Do you foresee this coming into the domestic market, Gutti, eventually?
What do you mean by domestic market?
Pay per lux, to homes basically.
Homes. Homes, I'm not sure. So definitely enterprises and governments definitely will go for this. The main reason is there is no capital expenditure, right? So you don't have to invest in buying this infrastructure upfront. You just use it. So I think homes, I'm not sure. But definitely for enterprises and governments, this is going to really actually it's already getting adopted
But
widely.
Relevant?
Sorry?
Is it still relevant? The prices of LEDs have come down drastically in last 5, 6
Yeah.
to 10.
So I will talk about that as well. So I'll talk about that as well. Yeah, definitely. They are coming down. I'll talk about it in the next couple of slides. And then last one here example is power tools as a service, right? This is, if you recognize it, this is Hilti Power Tools. Hilti offers equipment as a service, right, to job sites, right? So they offer their tools as a service to the construction companies, right? So they started this, I think, few years ago. Today, 50% of the revenues come from this business model, and they are growing at twice the rate of the industry. The rest of the industry is growing at. Right, so that business model actually changed the Hilti's finances very well. So now their competition like Stanley Black & Decker, Milwaukee are trying to copy it, but it's pretty cool.
Hilti started it, right?
Yeah. Hilti, yeah. Okay. All right, so that is a good segue, Paro. I'll hopefully address your question here. So I was at the right time at the right place in Philips in 2010 when they were basically transforming themselves from selling from products to services, right? So I was the product manager for this system called Smart Connected Lighting. Okay, what it did was simply it connected all the light fixtures of a city or even a highway to the cloud. So now you can remotely manage and monitor that infrastructure, okay, from your dashboard, from your iPad, etc. Right. So the bottom line, the reason why. So if you talk about smart city projects, right, you must have heard about smart cities a lot. One of the first projects a smart city a city tries to implement is lighting. Lighting, you drive by, you never notice a street light, but you notice the absence of a street light. So it's one of the most visible aspect or infrastructure of a city, right? So the mayor tends to prefer to invest into, of course, into something visible kinds of projects, right? So smart lighting is generally one of the first use cases they try to implement in a smart city. Again, besides that, of course, it consumes around 50 to 30% of energy for the city, right? So it consumes quite a bit of power to just illuminate a city. Right. So we started this around 2010. A lot of challenges, both on technical side and go-to-market. I will go into those details in the next slide. But here, just giving a very high-level view of what it is. These are street lights that talk to each other. They talk to a gateway, which in turn talks to a cloud. And then, if you are a city lighting operator, you just manage your infrastructure remotely from here. So when I say manage, what does it really mean? You can switch off, switch on, dim down, dim up, right? You can basically, if something breaks down, you can send a technician to fix it. All this reduces the energy costs and the maintenance costs. Believe it or not, I mean, 2010, 2011, when I was talking to a few customers at that point in time, most cities at that point in time did not even know how many street lights they had. Often they did not know. Okay, so you would wonder then how would they pay the electricity bill to the utility companies, right? Remember, they don't have meters, especially in US, right? So the way they used to pay electricity bill was they think they have 50,000 street lights, they burn for 8 hours in the night, so 50,000 multiplied by 8 hours multiplied by the energy cost, and that is the bill. That's how they used to pay. That's how they still pay, I guess. But things have changed since then. Often they would not know, how many streetlights are broken unless a citizen calls up. They would not have any clue about it, right? So that has changed by this connected lighting platform. Today, 30 million light fixtures are connected and remotely managed by this system. Okay, globally. Okay, so for example, one of the key marquee examples are Jakarta, Buenos Aires, Los Angeles. All of these are today managed by this City Touch and StarSense system. I was the board. Any questions on this? I can talk on hours on this topic, so I just want to make sure that I'm not rambling here. All right. All right.
Gutti, on in that
Gutti,
stack,
what impresses me is that Sorry,
Yeah.
sorry, please go ahead.
Go ahead.
In that stack that you have in that picture, do you use any of the public cloud based services?
Yeah, so we use AWS infrastructure as a service. Okay, the platform was built in house. Okay, but we used AWS. But before that, we had on-prem solution. Okay, and then we actually moved to the cloud.
Very interesting. And at some point, maybe you can comment on the Snowball and all those edge devices AWS is building. Maybe not this slide, but
yeah. So think about it. This was 2010. Okay, so IoT term was coined in 2008 or 2008 or 2009. Okay, so and SCADA, some people say that SCADA systems were like proto IoT. So some people say we were doing IoT before IoT was called IoT. Right, that's true to some extent. But anyways, in around 2010, there were no companies in the IoT. There are no vendors, basically, right? So everything had to be built in-house, right? From the sensor that sits on the fixture, the communication module that talks to other fixtures, even the platform had to build in on-prem. Then we eventually moved to the AWS infrastructure as a service. But everything had to build in-house, costed a lot of monies. And today, Paro, to answer your question, today we are more. What I hear is this whole thing, the legacy. Now they call it a legacy product, by the way. At that time, it was pretty cutting edge. Now they are moving to again give a little bit of explanation about lighting as a service, the Philips transformation journey. Why were they doing this, right? So what was the market? Let's start with the market need first, and then talk about the Philips's need. Right. Here, this example, lighting as a service, just shows an example how it's a very simplistic business model. So, for example, you are a city lighting operator. Your annual expenses today are $100,000 per year. Okay, including energy and maintenance, etc. Now, but you don't have money, and your infrastructure is aging. Let's imagine your infrastructure is aging. You don't have money to buy new lighting fixtures, right? LED fixtures, though the costs are reducing, but still you don't have money. Your municipalities are more or less bankrupt. You don't have money to buy it, new lighting fixtures. What would you do? So a company like Philips will come say, Mr. Mayor, we will replace all the infrastructure, lighting infrastructure in your city. We'll make it new, latest technologies will put in there. You don't have to pay anything. All you have to do is you have to pay us a fee, lighting fee for a few years. Okay, by putting in new technologies, we are going to reduce the energy cost and the energy consumptions, and as well as maintenance costs. Okay, all you have to pay is the lighting fee and the energy cost, which will be lower than your current yearly expenses. Right, for example, that will amount to 90K, and this 10K is the savings. Okay, you keep it. Right, you just pay us 40K as a lighting fee, or 50K here as a lighting fee, 40K for the energy costs, reduced energy costs because of the new technology. And you pay us this for a few years, okay, generally 2 to 5 years. And then after the end of that contract, you can do one of three things. You can decide to renew the contract, of course, or you can decide to buy that infrastructure at a depreciated cost, or you can decide to upgrade. Okay, you want now newer LED fixtures, okay, whatever. And so you can decide to do that as well. So basically, and often more often than not, they tend to renew or upgrade, right? So that is the basic service basic model that has become very popular now. Especially it started catching a fire in Spain. Okay, and again around 2010, 2013, that time frame, Spain was going through huge, especially the Spain cities were going through a lot of problems. Most of their municipalities were bankrupt, and they were looking for such fresh business models. Okay, so but the key is, all right. Anything else before I move on to the next? Garo, did I answer your question about LEDs or not at all?
Yeah, Guttedar.
Okay.
So I think
just brilliant, Gutti. Thanks so much, man.
All right. Okay. Thank you, guys. Thanks. All right. So moving on. So I was in this role for 3 years. Okay. This is the smart lighting role, and then they asked me if I wanted to go to China, and I said, yeah, why not? So around 2013, I went to China to manage a small business of automotive accessories. Okay, accessories. It was very small business at that point in time. And so one of the products in that portfolio that I was given was, curiously, was an air purifier. Okay, and I was like, "What the hell is this doing here in this in this company?" Right? It's a very consumer, some simple electronics that connects the thing to your app. Hello, somebody.
Gutti, one very interesting feedback for you.
Yeah.
I have a crazy friend in Delhi, Gurgaon, who A, is obsessive and B, is obviously concerned about the quality of air.
Yeah.
And he bought 4 different air purifiers, Philips, Xiaomi, Honeywell, and some other 4th one.
Yes.
He also bought an independent air purifier unit, which wasn't connected to the air purifier itself.
Yeah.
And then he carried out a series of tests, which he posted on Facebook.
Yeah.
And what was very, very interesting was that Philips was the only air purifier that actually reported correct AQIs that matched the independent filter that was not connected to the machine itself. Xiaomi, even if the filter was completely blocked and even if the air was not being cleaned, if you ran it for 1 hour, the ratings of the air would improve. And so it was quite incredible because he's just obsessive and does testing for a lot of devices. He posted this on Facebook and literally went viral, and Times of India also reported on it that Philips was the only one with a purifier that actually reported actual numbers. So just thought I'd share that with you.
Oh, great, man. See, one of this product, though simplest from a technical standpoint, was the most satisfying for me because I used to go on those Tmall, JD.com, all those e-commerce websites in China and read the comments of users, and I used to love it. Okay, I used to love it. This is something we created, we launched, and people are getting benefit out of it. It's still satisfying. Even today, I sometimes go sneak into those websites and see what people are saying. Thanks for sharing that, Kenneth. But we tried to launch this product in India around 2014. So anyway, so this is a product for retailer, brick and mortar stores. The key problem statement, pain point we are trying to address for the retailers was often the retailers, not often, almost always, they had no clue about the shopper behavior inside the store, the purchase journey for the typical shopper inside the store. Right, so there was no way they could personalize to some extent the shopping experience. Right, if you go on Amazon.com or whatever, before you even click on any product, the Amazon has already knows about you a lot and personalize your whole shopping experience to your needs. Physical stores do not have the luxury because they don't have any clue about people walking in to the store. So this product was built to offer those insights, basically, which enabled retailers to see who is walking into the store, at what times they're walking in, where are they spending time inside the store, but you can see the same. And then you can create a demographic, the heat map like this. You see the heat map here. The red ones, the red areas are the heavily trafficked areas, right? So you can slice and dice this heat map by gender, by age, all of that stuff. Right? It's all a cool AI stuff also we built in here. We'll go into the details if you have questions about how it was done. But the main problem was the main thing that it offers is the shopper behavior inside your store. Okay, what products they engage with, where do they spend time? And if you see here, this is an example of a hot food area inside a retail store, grocery store. Actually, hot food area is the highest margin area for a grocery chain. So if you see in recent years, that area has just has gotten a lot of focus from retailers, and hence one of the pilots that we did was. We can talk about this, by the way, offline again. All right. So this is going to be my last slide on predictive maintenance. Okay. So predictive maintenance, I believe, if I talked about killer apps earlier in the talk. I do believe predictive maintenance has a potential of being a killer app. Okay. So what is predictive maintenance? Very quickly, this is you want to predict the failure of a machine before it happens. Okay, so that you don't have any stoppages in the production, right? If for example, the machine is on the shop floor, factory shop floor, and you want to avoid the failure of it, you don't want to stop production, right? So you want to basically predict its failure much before it happens, right? So so the chart that you see on this on the left hand side is pretty probably well known to Bharat maybe, right? So all this reliability engineering guys would know this, right? So there are already existing technologies or techniques to predict failure of a machine. One of the early indicators you will get in the oil analysis, right? The oil, that is the lubricant that lubricates different parts in your machine. If you just take the sample of it and do a testing, you will figure out, based on the contaminants in the oil, you can predict whether this machine is degrading or not, right? After oil is a vibration technique, right? Vibration analysis. If you put sensors around your machine, take the vibration data, look it in the frequency domain, then you can figure out if the machine is off balance, if there is a bearing issue, all of that stuff. So you can do that using vibration analysis. Okay, and then thermal image. You can take a thermal camera and point to a machine, and you can see from the picture, you can tell what parts are going bad. So these are different techniques to help you detect, or at least detect the degradation before it actually happens, before the catastrophic failure happens, right? So these are the techniques that today already, these are physics-based techniques, I call them. Okay, these are very domain intensive. You need specialists to do this kind of analysis, by the way. So the oil analysis is pretty expensive. So is vibration analysis. You need special experts who do this. Now, what has changed in last few years is the statistical techniques to predict failures of machines, right? Where you don't need to actually even understand how the machine works, okay? Or the domain, you don't have to have a domain knowledge, very specific domain knowledge. As long as you have large amount of data and large amount of labeled data, right? So as long as your data set has data from machines at different stages of degradation, including failures, then you can potentially build a model which can predict failure of new machines without having to understand all this oil analysis, vibration stuff, all of that stuff, right? The pure statistical machine learning model. So that started happening in last few years. It has some problems. One of the problems is often you don't have labeled data because machines don't fail that often, right? That is one problem. And second is often it doesn't tell you the cause. It just tells you something is going to fail, but doesn't actually tell you what's wrong with it. Okay. So that is another problem with it. So there is a new paradigm coming along now these days, which I believe in, by the way, wherein you build those statistical models that learn the physics. Okay. That learn what these other techniques do, that learn what these experts do. Okay, and then you can use that. Once that knowledge is captured in that model, then you don't need them anymore, right? So basically, the statistical model learning the physics is something probably is a way to go. I haven't seen any product out in the market which is scalable, which is plug and play yet. So there's a lot of, if any data scientists on the team, on the group here, they will know building model themselves is not very hard, but the cleaning data engineering is the hardest part. In any data science project, 50% of the time is spent on data engineering. And that is very cumbersome, very time consuming. There is no easy way. So it's very hard to productize it. Basically what I'm trying to say is hard to productize this. This is one of the reasons why I think though this has a potential to become a killer app, has not become a killer app yet. Okay, I know Uma has a lot of experience with this.
Gutti, just to add to this, actually, just for those people who are curious to know, because this has been there for ages. This whole maintenance is like, since you were kids, people have been talking about it, but they're still trying to find the right way. But a couple of things that have really changed these days is obviously the processing power and the advanced model building capabilities, because in a lot of the times you need a transient modeling, especially in some of the cases. Even for example, a bridges, you take anything, you want to build the transient modeling. There are a lot of capabilities have come, but what is really making a difference is that the combined effect of IoT, using it for a building capable or advanced modeling. I think that's where a lot of the benefits people are seeing it, and I think people call it. I just wrote the acronym. It's called digital twin. Actually,
yes, digital twin. Yeah.
We do a lot of it. I mean, we have been doing this for 25 years on the power system, but again, people always come up with a sexy name for something. but again, question is, what's important is like a lot of the companies like ANSYS and all, they're coming up with a really sophisticated modeling, which people have not seen it. But this is also going to be a big game changer. Actually, if anybody's interested, we can talk. But this is a huge opportunity for building a big business actually in this area. I just throw it out.
I mentioned that in my, it's a huge potential. It's just finding out the right product which caters to a large enough market is what, one is looking for. If you think about all these factories, right, today, what is the most common machine on a factory? Can anybody guess? The most common is the motor, the pump, the rotary thing. Is the so if you can crack at least that, how to predict the failure of that thing, and some companies are trying to do it. Some startup companies are trying to do it. Then you have a brilliant product that can scale in terms of business.
Yeah.
Uma, you had a few things to talk about this. I know you have had experience as well.
Sure. Yeah, I think between Bharat and you kind of touched on that. So in the interest of time, I'll try to go for a short version of that. I think in the gas turbine power services side is what I have kind of hands-on experience. So the predictive maintenance, the way I transformed it is, for example, here in the nuclear, we service. So as part of GE's gas turbine business, we pretty much 99% of the revenue is maintenance, which is maintenance of the gas turbines. And if you take average life of a gas turbine, it's almost like what, 20 to 30 years even. So the way this predictive maintenance and IoT has transformed it is how field engineers service these turbines. And one area is, like in nuclear stations, each day is $1 million worth lost revenue for unscheduled maintenance. So what we're able to do now is look for indicators of potential failures using AR and some of the remote monitoring systems that IoT is enabling, and provide those services proactively to avoid the failures from happening. So there's already like several utility providers that are utilizing this today as we speak.
Yeah. So again, the predictive maintenance, one last comment I just wanted to make around it. So I spoke about cost to serve a couple of times in earlier my smart lighting story, right? That is the whole idea. So you want to, first of all, when you send a technician out in the field, you want to, first of all, make sure that he does fix it in the first go itself. First of all, he doesn't need to go, if possible at all. It can be remotely fix it remotely. Or and if you have to send a technician to the field, make sure that he does it in the first go itself. That means you need to provide him all the information about what has gone wrong, what is possibly wrong, all of that right in the beginning itself, so that he goes and fixes in the first. That is called first time fix rate, right? So the whole idea is to reduce the cost to serve your product out in the field. Okay. All right. So Uma, maybe that's
okay. So switching gears here. Yeah, I know each example here, I think we may have a separate session on itself. I mean, there's just a lot of application areas. So I'll quickly switch gears here. So I think there was general interest in industrial Internet of Things or medical Internet of Things, right? So if we look at the span, Gutti just gave a fascinating presentation on all the areas pretty much on, oh, thank you, Ken. I see that. So retail, we talked about retail, we talked about connected car, buildings and living. So most of what I have been recently in the last, I would say 10 years, I've been involved in is industrial internet. What that really means is if you imagine a system that has some type of automation, into it, and also PLC or HMI or some type of SCADA, that has some control or distributed control systems associated with it, then we go into the industrial Internet of Things. And there we have industry 4.0 is a very common term that is being used. So it's primarily like digital factory, smart maintenance we talked about, and how is IoT being utilized in the supply chain or commercial side of things. So I'm going to focus on some specific healthcare use cases as we move forward into this topic. So I think we are at a cusp of, many of us are in the, yeah, we can go to the next slide. Yeah, so we are in, we are in our early 40s, or, we are at a cusp of really either thinking about preventative health, how do we lead a healthy lifestyle? How do we make best choices for our own kids that give them a good lifestyle for the future? So with respect to that, I'll talk about a few monitoring systems that are evolving. I put a YouTube link here that Ken had provided earlier. What's the best diet for humans? So that's what that talk really addresses. That's a question that comes across all the time. a summary of the talk, I would say, if two of us, you and I eat the same thing, our body may respond in very different ways based on what we eat. Like ice cream may be very good for me, but not for somebody else, or not good for me, but maybe good for somebody. So that kind of thing, that's what the video really starts. So I think IoT is really helping us guide people on what's the best diet and what's the best lifestyle for each person. On the diagnosis side, again, in the biopharma world, a lot of application here. A huge area that I've been focusing on personally is the real-time monitoring of how cells divide. And I'll talk about why and how we are studying that. And sensors, I mean, are we Star Trek ready? There's sensors everywhere. So on the treatment side, again, remote monitoring, how can we treat people sooner and save lives? That's definitely increasing. And real world evidence, especially in viral vector development, or when you're designing new vaccines, how do we make sure we are taking real world evidence to quickly move from that clinical phase 1, phase 2 trials to commercializing the drug. So that area is again growing like anything, and a lot of machine learning, and Demon's talk I think will very much be relevant to some of these areas as well. So moving on to the next one. So the goal really is, if you can detect it here at a very early stage, as your cells divide, how can we stop it before it reaches, a malignant tissue and causes death even really. So next page. So let me pause here because it's almost the end of the presentation and we have given you overload of IoT already. So how many letters, if we were to call out, like if you think of yourself as alphabets, how many letters do you think are needed to describe you? Just voice it out or type in chat, whatever you prefer, yeah. I'm not hearing anybody say anything. Any guesses? 1 letter per year. 1? All right. I think we are very far off. Any other guesses?
10,000.
I think Kenneth knows.
No, I don't want any of the organizers. All right. So just in the interest of time. So the reality is it's almost, it's not in thousands, it's not in millions. So any other guess? 500? All right, let's get the answer here. So we are a little way more complex than we think we are. So it's actually 3.3 billion. That's the real number here. And putting this in perspective, I have included a link that many of you will enjoy reading it. It's from a site called Information is Beautiful. So you can take a look at it, putting this in the context of, how many letters or lines of code make a Google, search engine work. This is way bigger than even that, as an example. So that's really what we are working with in the biopharma world. Most of the times, we are working with DNAs, and there is that much more DNA in every one. We have trillions of cells in our body, and there is that much more DNA in every cell of our body. So that's what makes it complex. And I think IoT is really enabling us to study the cells. So in our body, what's happening is cells are constantly dividing. And when they don't, when that machine of dividing cells stops functioning, that's when some really bad things happen. So things like cancer or things like immuno diseases or some syndromes happen when even before life is born. So what IoT is enabling is looking at that before it happens and helping save people and influence medical intervention as needed. So if we go to the next page here, I'm going to jump into the use cases here. So this is a most recent use case that we have been working on. So I'll pause here. I'm talking a lot about the biopharma cell therapy. So maybe I'll just tell you a very high view of, on the medical diagnostic side, most of you will be familiar with like CT scanners, X-rays, MRI machines. In the biopharma, what we mean is cells that are taken or in many cases could be harvested from your own body. So this is very highly individualized medicine, and the cells are injected back in some way. It's put back to the person that originates it. So I think in general, I mean, one of the most prevalent diseases in this area is cancer. We have more than 1.7 million new cases in the US alone. And what IoT is helping us do is get a deeper understanding of this immuno-oncology. So most of the times when we get cancer, so there is surgical intervention, there is drugs, obviously there's radiation and chemotherapy, which is what is traditional ways of, almost all of us would either know somebody or may have first-hand experience of dealing with people that have had some of these immuno-oncology type diseases. So in the cell and gene therapy world, it's fairly time and resource intensive. And what I mean by that is, if you click one more time, Guti, what this process involves is really collecting the cells. So you're taking the cell from the person that is that has this disease, you're processing the cells in a controlled environment. So that's what we manufacture. So what I'm involved in is all these equipments that will help. Almost you can imagine it like a highly complex beer, like the beer making cells of some kind into which human cells are put in. And the cells are processed in that environment and the cells are injected back to the patient. So there is a large aspect of obviously data security and the privacy aspect first of how, and if you look at the end-to-end life cycle, the way the human body processes the cells is not the same as how it would be when you put it in an outside world. So one of the product that you see on the left-hand side that we have been involved in is unified digital platform. So this will help monitor the facility manufacturing operation and supply chain logistics. And IoT is helping improve the workflow because the more you can monitor the cells as it grows and divides, you can ensure that it is going to be in a form that will allow that person to successfully live his lifestyle and go back to being what it is. So that's where it is. And we talked about data engineering a little bit. So huge potential for machine learning and data engineering. So there's a lot of engineering of the data before you can work on any of that data, before any work can even start. So I think that's one example on the cell therapy side. So what we are doing here is we don't touch the part where the patient to the hospital, that data set is maintained by the hospital or another governing body, if you will, in the entire data ecosystem. But once it comes there, the cell needs to be grown. So you can almost imagine it as you're growing the cells, you're making sure there is the right level of antibody, right level of protein, you're harvesting the cells. That's the place we, at least the product that I've been touching is heavily focused on. So what that platform lets you do is, the real-time monitoring of this gets very tricky because the cells are constantly multiplying inside that bioreactor or in a downstream equipment. So once you do that, then you are able to harvest it. Then it's another distributor company. Then our involvement right now is this product doesn't focus on the rest of the value chain, but there's another aspect of the value chain where the cell is going back to the individual. So that's one of the biopharma examples that I wanted to share. The next example I had was around diabetes, which is again a very okay. This is actually an in-cell analyzer picture. What you see here. So this is a live picture of how your cells are dividing. This is zoomed up a little bit, 4 times the real speed. But if you were able to remotely monitor this, it's going to enable quick intervention to address, if, oh yeah, I don't see the cells dividing as expected, or, I'm seeing in like sickle cell leukemia, these cells are not, you're almost going to look at the green picture as two red spots essentially. So that's what is happening. And on the right-hand side is heart monitoring. I mean, again, cardiovascular diseases is another area IoT is heavily impacting. So doctors are able to monitor heart cells beating real time and intervene even when somebody has undergone a bypass surgery or somebody is, with AI, they're able to figure out whether or not this person will likely have a cardiovascular issue in the future. So those are the 2 examples here that I wanted to give. So I'll pause here. Any other thoughts, or maybe people have your own examples to share too?
So Uma, the question is, once how does this transform to drug making for diabetes? How do you use this data to go on about making a product?
Yeah. So, like I was telling you, there are two aspects of drugs, right? So we have what we call, I was telling Guti earlier, small molecules and large molecules. In small molecules, you're working with less than 100 atoms. So it's fairly, you don't need, you still have some level of data science that will help there. So that's the generic, drugs that you can imagine, anything like Prozac or ibuprofen or Advil. Those are all the small molecule type drug. In large molecules, which is what is specifically targeted for vaccines or even for cancer, Alzheimer's, those type of Parkinson's, diabetes, those type of diseases, you're talking about anything from 2,000 atoms to 100,000 or greater number of atoms. So to your question about how does this change, a lot of drug manufacturing is about maintaining the cell growth within a controlled environment and being able to monitor it. And it's very, very hard to maintain that cell growth. If you look at yield or what's the loss that is happening from a supply chain standpoint, not being able to monitor the right parameters, it's pretty huge. And that's where these technologies are starting to help big time. Does that answer your question, Anand?
Yeah, got it. Makes sense. Thank you. I'm impressed that you have gone from turbines to atoms in your career. Pretty amazing.
Yeah, I mean, it's. I think it's a different. Yeah,
she's expert in biology now.
Yeah, and I mean, when I hear her talk, it would be like, oh, so she's been in medical field for years. Amazing. And then good job also.
Constantly, yeah. Another thing we are constantly doing is majority. I think a lot of interactions I'm having right now is with like either scientists or biochemists or some type of biotech background people, and I'm constantly learning too from them, which is interesting.
Yeah, this was great, guys. Very good session, actually. Guti, huh? Nice to hear. Yes. Yeah.
Hey, you have is Uma still there?
Yeah, I'm here. Yeah.
Did you go through these examples?
No, I just have one more. So the diabetes example is, about, again, the stats are obvious. People don't really need that. So here, from my involvement, it's been in the insulin medication, how 90% of insulin that's used by anybody is provided by, can you go to the previous page? Yeah. So continuous glucose monitoring is one, and I'll let people watch that video too, because you can kind of relate to how, if you know somebody that has this, you really see the benefit. Because eat and have a very normal lifestyle, unlike having to monitor after every meal what's going on in their life. So third use case, I know we are a little over time, so I'll just come to the next one. This is on the vaccine development use case. So this chart may be useful because I've seen a lot of people discussing around what it really take to develop a vaccine. So I'll use a very simple cookie example here. So in a cookie example, so if I bake cookies at home that are really nice, my kids and husband, the family enjoys it first and they say, wow, these are really great. Let's try it. Let's give my kids friends. So you give the kids friends, they like it too. Then you take it to a small, a few sets of shops or one shop. And then the shop says, oh yeah, we have all these criteria that you should meet before I can commercially buy it from you. So then there's that licensing and you have some regulatory things to meet to show that I have all these, coming from a controlled environment. And after the licensing, you also need to be able to, let's say your cookies are really well received and more people want the cookies. You want to be able to bake the same cookies every single time. So that's really what's happening here. From preclinical, what we call as phase 1, phase 2, and then licensing and after licensing. So in the preclinical stage, in a vaccine, you're often you're looking at antibodies. So antibodies having a hit rate of, is this even the right antibody for this type of issue is a challenge. So where IoT is helping is minimize the you can optimize a hit rate based on machine learning model and figuring out which type of antibody is suitable for which ones and things like that. So 128 million to 69 candidates in less than 1 year is what we have seen. And then clinical and licensing, I talked about real world evidence briefly. So the area that is growing hugely. The commercialization side, asset optimization, just I think Praveen touched on that early on in his question around how to scale from smaller number of assets in his company to having a lot more. A lot of different assets connected to each other, and this is also very relevant in a home. I have 2 devices. I want to connect 10 devices or something like that. So I think in general, the message is IoT is changing the way we work in every phase of drug life cycle as well, drug development, and then also the pre-drug development. The question on the chat, sorry, that just popped up. Let's see, estimated reduction of drug due to time. Yeah, okay. So I would say that it's almost, I would say from years to months. I mean, right now, the least I have seen is Moderna. Sorry, can we stop the recording for just a second here? Because I'm using some.
Connected and more complex, generate more and more data. It's going to happen that IT is eventually going to take over. Today, if you go into any manufacturing plant, the IT that runs OT, right, is managed by a totally different team. Okay, not necessarily the typical IT folks that you interact with, right, with your laptop, etc. But over the time, I believe there is a trend where the IT organization is going to take over the OT as well, simply because IT knows how to handle huge data. They've been trained with that. They know they have the processes, tools in place. And OT people are not equipped with that at this point in time. So eventually conversion is going to happen where more or less I would say IT is going to take over OT. Okay, so there are opportunities there as well. I think no one has figured it out yet very well. Okay, most of this, I talk about IoT platforms, right? There are general purpose IoT platforms like Microsoft and AWS. Then there are industrial IoT platforms like Siemens, MindSphere, Honeywell has one, I'm forgetting the name. So these are basically, these systems do not talk to each other today at this point in time, right? And there is a need to converge the systems so that you make business decisions based on both information, right? The third point is IoT infra outsourcing, right? Let me explain what that means. So today, most of the IT infrastructure of big corporations is managed by our IT services companies like HCL, Accenture, Wipro, etc., right? The similar need is going to come in the IoT world as well. Once you get millions of devices connected in the field, somebody has to manage it, right? Who is it that going to be managing it? Today, the company themselves, the OEMs themselves are trying to do it, but I don't think they will be able to do a good job at it. And besides that, it is not their core competency anyways. So that outsourcing, IoT infrastructure management outsourcing, I believe is going to happen sometime or another, right? We have already seen some RFPs in that area where Kone elevators, Fortis elevators are basically asking IT companies to manage their infrastructure, connected infrastructure. Right. Sachin, I spoke earlier, right? It's a very complex ecosystem, IoT. And so there is a lot of consulting opportunities here, simply because end customers do not still know how to navigate this ecosystem, how to build the whole IoT roadmap, their IoT journey. So they would need handholding. Digital thread, digital twin, we talked about, Bharat, right? So that is a new sexy term that is being created and used. If Naveen is on the call, he would say this was not only it was being done in power systems, it also being done in semiconductors, right? The whole transistor model was nothing but a digital twin, right? The simulation of a transistor, of a circuit using transistor models was nothing but a digital twin concept. So it was there, the concepts were there, but it is being now applied to larger systems, okay? How successful they have been so far, I don't think they have been very successful at this point in time, but there is something up and coming now. Blockchain, I don't really understand very well. There are some use cases we have built around blockchain, but it's just something I could not get my mind wrapped around very well.
Yeah.
But
if I can just add that blockchain, I mean, just as I know we're running out of time. The time was, I think, one use case at least in energy sector, the blockchain becoming very prevalent is in the area of distributed energy resources. And it's like, for example, if everyone has a solar on their rooftop, how do they commit and how do they sell? The concept is that you don't have to sell it back to utility to sell your neighbor, actually, right? So anybody can buy from anybody. I mean, it's a very high level, but in that space, there are a lot of opportunities in blockchain in energy sector, at least, which I'm.
Oh, that's a nice use case. I never thought of it. Okay, interesting. Most of the IoT and blockchain use cases I've heard in the supply chain logistics domain, but that was a very interesting use case. On AI ML, scalability is still a problem. What I mean by that is, right, I think Dimant is going to talk about it. All these machine learning models you're going to build, they eventually going to get deployed on the edge or on the device themselves, right, for inferencing. Once they get deployed, who is maintaining them? Who is making sure that they are being upgraded? That whole ML ops still is broken, I believe, okay? Especially when you have hundreds of models deployed in over thousands of devices. Managing that is a problem. There could be opportunities in that space as well. We can talk in details and offline if any of these interest you.
Yeah,
but that is
again,
all
just to add to this security, guys, I mean, just one thing, again, I'm just throwing some acronyms so people can do more research.
Yeah.
The IoT is a very big thing. As a company that we work, we almost control about 35 to 40% of the whole electric grid of US, I mean, barring the rest of the country. So imagine it's a critical infrastructure. There is a regulatory framework called NERC-CIP. NERC-CIP stands for NERC, CIP stands for Critical Infrastructure Protection, NERC is for North American Electric Reliability Council. So there is a 7 section, there's a clearly defined guideline that every utility has to comply to actually, and that clearly defines a lot of the IT/OT cybersecurity requirements. And there's a lot of opportunity, those folks who are interested in either consulting services or the building some applications or products. So you guys can go and do some more research. If anybody's interested, we can discuss.
Hey, Bharat, can you type that acronym, whatever you just said?
Yeah, I'll do that. NERC-CIP, NERC-CIP, I'll type that. Yeah. Sure. Okay. Yeah.
So Ashish, Uma, a question for you guys. As you talk about all this new stuff coming out, how do old dogs like me in oil and gas try to make a transition to a growth area and be successful there?
Anand, that's a nice segue to comment or a point I forgot to mention in my earlier part of the talk. Right, in oil and gas, a typical rig, I hear, okay, you are the expert there, but I hear a typical rig probably has around 20 to 30,000 sensors, okay, a typical rig, and generating a lot of data. I believe only 1% of the data is ever analyzed. That is coming
even
out of
less than that, yeah.
Yeah, that's what McKinsey says.
Right.
So that is the space you can work in, right? Solve that problem.
So how do what's the? I was the guy who used to collect the data 15 years back, so I understand what you're saying.
Yeah.
In fact, Anand, just as an aside, we were in California a couple of months back, and one of the guys we met with there only specifically focuses on oil and gas because the cost of these sensors, like somebody else was saying, that cost of these sensors is so expensive, etc. Oil and gas is one of the industries where they're completely indifferent to the cost because the downtime is so expensive for them. That a lot of this just makes sense in oil and gas more than it does in any other relatively richer industry.
Right.
So Anand, basically analytics, man, data, big data. I know these are big terms, and there are many experts here on the. So Anand, Monty, Nitin, I guess are experts in this area.
So are you suggesting that? And the reason I only ask is, oil is at 40. There is so many of my friends on the road looking for jobs. Are you guys suggesting you guys need to learn, take classes in data analytics to be able to play here, or what is the thought here?
I think an MS in data science is not a bad idea for many of us. My boss, who was heading the automation, practice in Bank of America, he did a part-time MS in data science. So I think we are domain experts. Anant, you are a domain expert in oil and gas. That's your strength. That is one of the legs that you sit, of your chair. But how do you add some of these skills in order to double down your core strength is really how I would look at it.
Yeah, I told that to Anand earlier as well, right? So some of these IT companies and consulting companies will value your domain knowledge more than the other technical knowledge, because technical knowledge is available. I won't say it's commodity, but it is widely available. Okay, but the domain knowledge, oil and gas, it's pretty rare. It's not
Anand,
it's not
we
widely
did one
available.
experiment in our company. We trained a mechanical engineer who was MTech Energy on analytics. So we tried to train IT guys on learning domain, and we tried the domain expert, training the domain expert on data analytics. Training the domain expert on data analytics was much easier than the other way.
Yeah, see,
IT guy could not pick up domain. It actually
correct.
So it worked very well for us.
Yeah, even data science, right? So I don't even think we need to do an MS, but I believe I took a course on Coursera. Okay, I did all those Andrew Ng's 7 courses. I initially thought I'll just watch the videos on machine learning. Okay, that's about it, because I am a product guy, marketing guy. I don't have to build stuff, but I started liking the courses and even doing the coding as well. So those 6 or 7 courses that you have on Coursera, they're absolutely beautiful courses. Okay, and if you come back, if you have enough little bit of maths background, you don't need to even know programming, but you'll start picking it up very easy.
Can you send the link?
Yeah. Coursera, you just look for Andrew Ng, Andrew NG. He's pretty popular, right? Guy in machine learning. Okay. Stanford University. Yeah.
All right, Amit Rao, go ahead, man.
Well, I think before you hang up, guys, I think Gutti has the trailer for the next show to be shown.
All right. Okay. Where is that, Uma?
Oh, actually, it's in the previous page. Sorry, let me just put it in the chat.
You can take control, I guess. Yeah.
Give me a second here. Let me get it ready.
So I think the next session works very well with this current session.
Yeah.
It's on a technical track, AI and 4G, and 5G.
Yeah.
Yes, G.
So yeah,
Guys, please put the comments on the main group. Don't type here, please. Please type on the main group.
I'm going to share my screen.
Yeah. Go ahead and share. Yeah.
Coming.
So Bharat, where are you located?
Minneapolis.
Wow.
Warm place. You?
It's going to. I'm Redmond, Seattle. Okay. So Minnesota is turning red. That's what I hear.
Yeah, started. I see my maple trees are already red now.
No, it's not that way. I'm talking politically.
Politically core, become black now. So.
Hey, I'm in Houston. If anybody cares.
My screen yet?
Yeah,
that's coming up.
It's coming up.
Okay, great. Yeah. I will start playing the trailer as soon as you all can see my screen.
Yeah.
You can say. Go ahead.
Yeah.
Go ahead.
Yeah, this is you're going to have fun at this session, I'm pretty sure. Next one.
You need Demon to give you a better processor, Uma. It's so slow.
I don't hear any.
You need to share the audio, computer
audio is missing. Yeah.
No, when you click share, or there should be options there. No, not there.
In Zoom.
In Zoom, yeah.
Oh, in Zoom, okay.
The easiest way to do is unshare first and go back to sharing. While sharing, at the bottom you see a checkbox.
Zoom machale, Uma.
Bala.
Yes. Great.
Bala is our Zoom expert now.
Yeah.
Yeah. Hello.
And trailer expert.
IT support.
IT support. IoT support.
IT and OT को mix करोगे तो IoT बनेगा ना.
Right.
Too many acronyms today, man. I don't need to eat my dinner.
Too much salt in your dinner anyway.
You're back to it again.
Yeah.
When the screen for sharing comes at the bottom, there is an option to share computer audio.
Okay, hang on. I'm having trouble sharing. I don't know why. Give me a second.
Or Amit can do it.
Bala, why don't you go ahead and share yours?
Oh, hold on. Right, where have I put this?
Hey, Ashish.
Bharat, hands up also. Like
Yes,
this.
sir.
Yeah. You're also on the manufacturing side, on the IoT, from IoT point of view. When you talk about IT, OT, that was more from the manufacturing perspective.
Yeah, manufacturing side. Yeah, there is a whole world out there in utilities as well, which is what Bharat is talking about. But I was talking about manufacturing. Yeah.
But then Gutti, in all this presentation, you're using a wired cable for your earphones. That just sucks. IoT ka presentation you're doing is wired.
He's waiting for 5G.
Okay, are we ready? Oh.
Uma has started sharing again.
Oh, sorry. I was trying to pause, but I instead let me.
I'm going.
Uma, take your time. No pressure, huh?
Yeah, take your time.
Can you guys see my screen?
Yes.
Somebody's screen.
We can see your brain.
Bala, why is it empty?
That's just how I was born.
The road trip, where anything can happen, and usually does. Get ready to raise the stakes when the road trip becomes the road chip.
Buzzkill.
Wow.
Oh,
awesome.
That's cool.
I need an intro. I know who to tap into.
It's like raising the bar every week, actually. Yeah, every time.
That's Bala.
We are like singular that way. Raising the bar. All right, great.
All right, guys.
Thank you for participating. Any last questions for Gutti and Rama? If not, thank you everybody for participating.
Thank you, guys. Thanks
and
for
make
all
sure to
subscribe
to the next session.
I'm going to ping you offline.
Yeah, sure.
Catch up
Thank you, guys. Thanks.
Thanks for the wonderful session. Uma,
yeah, total right.
so lovely to hear you all. Yeah.
Thanks,
Amazing, amazing.
Thanks,
knowledge.
Thank you. Gutti, thank you.
Good weekend. Hey, Pillai.
Thanks,
Good
everyone. Enjoy
weekend.
your
Very well.
Bye.
Bye.
Happy Labor Day.
Bye. Yes.